Fundamental theorem of calculus, area function. So whenever we have a function fx being integrated from a to b, so suppose we have a function say fx and we are integrating from a to b. Here a is known as the lower limit, this is known as lower limit, and this is known as the upper limit. So whenever we are integrating a function fx from a to b, then it gives the area, it is equal to area bounded by the curve y equal to fx, then x-axis, the line x equal to a, and the line x equal to b. So we'll getting this area. This is the curve y equal to fx, is bounded by the line x equal to a, x equal to b, and the x-axis. So whenever we will be integrating the function fx from a to b, what we will be getting is the area below the curve till the x-axis bounded by the lines x equal to a and x equal to b. Now let us go in this further. So we are having here fundamental theorem of integral. The first one is, let f be a continuous function on the closed interval ab and let ax be the area function. Then if we differentiate that area function, what we will be getting? We will be getting the function fx for all x belongs to closed interval ab. Then second one is very simple one. Let f be a continuous function defined on the closed interval a to b and f be the antiderivative of f. That means on integrating fx dx, we are getting the answer as capital Fx, and the limit is from a to b. Then the value of this will be f capital Fb minus capital Fa. So let us learn this with the help of an example. Suppose very simple example we are taking. We are integrating function say from 1 to 2, and the function is say x dx. So x we are integrating with respect to we are integrating the function fx with respect to x. So answer of this will be equal to x square by 2, and 1 is the lower limit, 2 is the upper limit. So the value of this will be equal to, just we have to put the value of in place of x, just we'll put first 2, and then we'll put the value of 1 and then subtract both of them. So it will be like this: 2 square by 2 minus 1 square by 2, and this will give us equal to, so this is 4 by 2, that is 2 minus half, and that is 3 by 2. Exercise 7.9, question number 1. So solving question number 1, solution 1, I equal to integration of x plus 1 from minus 1 to 1. So how to integrate this? Very simple one. First just we'll keep the lower limit and upper limit in square bracket, and we know how to integrate this, so it's very simple. Just we'll integrate x plus 1, so we'll be getting here x square by 2 plus x, and here on the top we'll write upper limit, and at bottom we'll be writing lower limit. So equal to, just we'll put the value of the upper limit first, so it will be equal to 1 square by 2 plus 1 minus, then we'll put the value of the lower limit in this, and then do the subtraction of the upper limit and the lower limit values. So minus 1 by minus 1 square by 2 plus minus 1, so equal to, this will become 1 by 2 plus 1, and here minus as it is, so square of minus 1 is 1, so we will be getting here 1 by 2 and minus 1. Opening this, will be getting half plus 1 minus half plus 1. If you want, we can simplify this and this, and subtract. That's going to be done. Now plus half and minus half will cancel each other, and the final answer will be 2. So the answer of the value of the definite integral from minus 1 to 1 of x plus 1 is 2. Now question number 2, exercise 7.9. See here, to solve this definite integral is very simple, because we have already learned how to find the integration of indefinite integral. So what we have to do is just find the just integrate the function and then put in the upper limit and the lower limit, and then subtract both, and we'll be getting the value of the definite integral. So very simple, not difficult at all. So let's just try this question number 2. So solving 2, I equal to integration of 1 by x dx from 2 to 3. 2 is the lower limit and 3 is the upper limit. So we already know how the integration 1 by x. Therefore, we can write I equal to log mod of x. And what is the lower limit? It is 2, that I will always write at the bottom, and 3 at the top. So therefore, I equal to, now putting the upper limit first, so log 3 minus, then subtracting with the value of the lower limit, there is log 2. Also we know that log a minus log b is log a by b. Therefore, I equal to log 3 by 2. So this is the answer of question number 2. Not difficult at all. Now this third one you can try on yours. That is for self try, because you know how to integrate a polynomial function. Then let's try this next one, that is question number 4. So we'll be trying question number 4th one. Question number 4, exercise 7.9. So I equal to integration of 0 to pi by 4 sine 2x dx. Sine 2x dx. Therefore, I equal to, we know the integration of sine, that is minus cos 2x by 2, and the limits are 0 to pi by 4, and therefore we'll first put the value of the upper limit, that is I equal to minus cos, in place of x we'll put the value of x, that is 2 pi by 4, 2 into x is pi by 4, the whole divided by 2, and this whole 2x is not being divided by 2, but cos 2x is being divided by 2, and this will close, then minus, as it is here, minus one more is there, minus cos 2 0 over 2, this is 2 into 0 over 2. So therefore we will be getting I equal to, now this can be cancelled out, and we know that cos 90 is 0, so we will be getting minus 0 over 2, that is 0, and minus, and this minus is plus, and we know that this 2 into 0 will become 0, so cos 0 is 1, so we will be getting here 1 by 2. So the final answer is 1 by 2. So the answer of question number 4 will be 1 by 2. Question number 6. So solving 6th one, solution 6, I equal to integration of e raised to x dx from 4 to 5. Now therefore I equal to, we know the integration of e raised to x, the limit is from 4 to 5. So therefore I equal to, first we'll put upper limit, and then from that we'll subtract the value of the lower limit. So I equal to e raised to 5 minus e raised to 4. So this is the, and if you want you can take out common also. I equal to, you can write as e raised to 4 into e minus 1. So this is the answer of question number 6, exercise 7.9. Now let us go in question number 7. So this 7th one, so solving question number 7, solution 7, I equal to integration of 0 to pi by 4 10x dx. So therefore I equal to, we know the integration of 10x is log sec x, so we will be writing here log sec x, and the limit is from 0 to pi by 4. So therefore I equal to log sec pi by 4 minus log sec 0. Therefore I equal to log, now sec pi by 4 is root 2, so log root 2 minus sec 0 is 1, so log 1. Therefore we can write I equal to this root 2 means the exponent is 1 by 2, we can write as half log 2, and we know that log 0 is 1, so the final answer will be half log 2. Then let us go in question number 11. So 11th one, I equal to integration of dx over x square minus 1 from 2 to 3, and we know the integration of dx over x square minus a square. So this will be given as equal to 1 by 2a. A is 1 into log x minus a over x plus a, that is x minus 1 over x plus 1 mod of that, and limits are 2 to 3. So equal to, putting the upper limit, will be getting 1 by 2 log 3 minus 1, that is, this will give us 3 minus 1 is 2, and 3 plus 1, it will give us 4. Then minus half log, putting the value of 2, 2 minus 1 is minus 1, and 2 plus 1 is 3. So equal to half, you can take count from both. So here we will be getting log 2 by 4, that is log 1 by 2, and minus this mod is there, so it will become log 1 by 3, and this will give us equal to half, and we know that log a minus log b is log a by b, so log half over 1 by 3, and simplifying this further, equal to half log half into 3 by 1, that is equal to 1 by 2 log 3 by 2. So this is answer of question number 11. Question 15, exercise 7.9. So solving question number 15, solution 15, I equal to integration of 0 to 1 x e raised to x square dx. So this can be written as, therefore I equal to, limit will take from 0 to 1, and here integrating x e raised to x square dx. Now we know the difference of x square is 2x, so we will multiply and divide with 2. Therefore I equal to integration of 0 to 1, here dividing with 2 and multiplying with 2, so we will be getting a 2x into e raised to x square dx, and 0 to 1. Therefore I equal to, now here remember the limits are in terms of x, so this is x equal to 0, x equal to 1. So suppose we take suppose we substitute x square as t, then we keep the limits as 0 and 1, then it will be wrong. So what we will be doing, we will just mentally calculate that. Therefore I equal to, half is as it is, then integration of 0 to 1, suppose x square is t, and differentiation of x square will be 2x dx, so we will be getting here e raised to t dt, and integration of e raised to t dt is e raised to t. So what we will be getting here is e raised to t only, so that is, we will be getting the answer as e raised to x square. So limit is from 0 to 1. So this is how we will solve it. Remember that do not put t, because when you put t, you will have to change the limit also, because here x equal to 0 and x equal to 1. Putting x square to t, this whole function will be converted in terms of t, but the limits will remain in terms of x only, so it will be incorrect. And that method, how to change the limits, that we will learn later on. So right now, what you have to do is mentally calculate this. So keeping in your mind that we have taken x square as t, so difference of that will be 2x dx, that is dt. So we are getting integration of e raised to t dt, that is e raised to t. So answer is e raised to x square. Now we will put the value. Therefore I equal to putting the value of putting the upper limit first. So we will be getting half is constant, so it will remain as it is. Here we will be getting e raised to 1, so x square is 1, and minus e raised to 0, so equal to half e raised to 1, that is e minus e raised to 0 is 1. So the answer is half e minus 1. So this is the answer of question number 15. Now questions for self trial. Questions remaining will be for self trial. Questions remaining are all for self trial. Are all for self trial. So whatever questions we have not completed, that you will try them, because they are very simple one. Already you know how to integrate. Just have to put the limits and get the answer. So questions remaining, that means which you have not solved, they will be all for self trial. So with this exercise 7.9 is complete.